Welcome to Altair Engineering Training and Support. I am Apurva Bhatt. Welcome you all in Baja SAEINDIA 2016 online training sessions. We have already covered day 1, day 2, day 3. So today we will see on day 4 how to mesh, knuckle and hub. Those are the 3D components. How to solve those 3D components applying multiple load cases simultaneously. That is combining 2 or more loads and viewing the results. So today we are going to see the 3D meshing and analysis of knuckle and hub. So as we are going to solve this using linear static load case, so I'll select a user profile as OptiStruct because for linear static analysis the solver is OptiStruct. So I will select the user profile as OptiStruct and click OK. Then I will load or import the geometry file of knuckle and hub. So I import the geometry file of knuckle or hub. I will first import knuckle. So you can see here, this is my geometry for knuckle. So in 3D meshing, there are two approaches. First is you can directly mesh a 3D component using tetra mesh panel, or the other way is first you can create a 2D mesh and then you can convert that 2D mesh into a 3D mesh. So I will show you both the options. First I will show you first creating 2D mesh and then converting it into 3D meshing technique in knuckle, and then for the hub I will directly mesh the component using tetra mesh panel. So I will follow the same process, that is first create the material, then property, then component and meshing, applying the loads and conditions, load step and all. So for 2D meshing, I will go to 2D panel, auto mesh, select all the surfaces, select R trias, element size to say 4, element to surface component, first order, keep connectivity as it is and click on mesh. So this will mesh my complete geometry. You can see here. I will click return. So this is my 2D mesh model. You can see here. If I mask this, so this is hollow inside. Once I do 3D meshing, it will, the elements you can see inside also. So for 3D meshing, before that, why 2D to 3D is more accurate, because we can edit the 2D meshing, and once we convert the elements from 2D to 3D, the chances of getting errors in 3D elements will be less. So I will press F10. First I will check Jacobian, warpage, aspect ratio, minimum angle. So my sum of the angles are 0. So I will try to find it to 15 degrees, how many are failing. So 8 elements are failing. So I will click on save field, mask, elements, retrieve, reverse and mask, shift F2, add the nodes, click on unmask all. So these are the elements which are having very less angle. So I will just try to increase the angle. So 1.2. Similarly here also the angle is very less. So I will first delete this element and merge these two. So with this. So I will add some more nodes. So here you can see it has created a line. So I have deleted it. Now I will create some elements. So to create the elements, press F6 from your keyboard, trias. So this, and this. Similarly this and this. Then from here to here, from here to here, from here to here. So this is done. Similarly here also, I will try to increase the angle by increasing the length. Here also it's failing, so I will increase the angle. F10 minimum angle. So 11 is a good number. 145 it's okay. So my 2D meshing quality is quite okay. So now I will press Shift F3 from my keyboard and check for the connectivity. So I will click on tolerance value as 0.1, preview equivalence, and find edges. So at the bottom of my screen you can see no edges were found. Selected elements may enclose a volume. So that's what I want. So all these elements should enclose a volume, otherwise it will not get converted into 3D. So if there is any free edge, my elements will not get converted into 3D. So I will add one more component here, 3D meshing. Define a separate color to it. Without any property, I will just create it right now. Then I will go to 3D page, tetra mesh, float trias, chords to tetra mesh, select all the elements and click on mesh. So once I click on mesh, you can see here it has meshed it into a 3D component, you can see. So now I'll show you both. So you can see I have this 2D meshing in another component and 3D meshing in the another component. So once my 3D meshing is done, I will delete the component having 3D elements. So now only thing I have is the 3D meshing. I have deleted the component which is having 2D elements. I don't want to take two types of meshing to the solver because otherwise it will create an error or issue for me. So I only want one type of elements to take that in the solver. So now I will start the process. First create the material as steel. Define a color. Type isotropic. Card image matte 1. Create edit. E. I will try to edit it from here. So E new row, it is done. Then property, 3D knuckle, define a color, type 3D, card image P solid, material as steel. If I click on create edit, there is nothing to provide the input here. Then components, update the component with proper property and material. So my material, property and component updation is correct. So I will quickly check with the elements color. So I got a property color on the elements, material color on the elements, my components color on the elements. So I quickly check with this. Now I will proceed towards the application of load. So there will be so many load cases which will come on the knuckle which you can solve. That depends on your knuckle type or the critical load cases which you assume which will come and will try to fail the knuckle. So I will show you few of them, how to solve them, and in a similar way you can solve all of them. So the first is, I will take three major forces. One is torque, the other one is bump force, and the third one is lateral forces. So I will apply three loading condition. One is torque, one is bending force, or sorry, braking force, and one is axial forces. So I will constrain. See, there are two ways to apply the loading conditions in the knuckle. One is from the tire side. Once you apply forces on the tire side of the knuckle, so then you have to constrain the roll gauge side of the knuckle. If you try to apply the forces at the roll gauge side of the knuckle, then you have to constrain the tire side of the knuckle. So one you have to constrain, the other round you have to apply the forces, so that you will get the results. So now for this case I am going to apply the constraints at the roll cage side and apply the forces at the tire side. So before applying the forces, I want to create a rigid element so that I can directly apply the forces and constraint on the rigid elements, and it will directly distribute the loads and forces to the entire geometry. So to create the rigids, first I have to create component of the rigids. So I will enter the name as rigids, define a color to it. Without a property, I will click on create. So I create one more component as rigid, and I will create rigids on it. So for rigids I need a center point of all the holes. So to create a center point, I will press F4 from my keyboard, go to three nodes, pick any three nodes and click on circle center. Similarly here also I will pick three nodes and click on circle center. Then with the help of these two nodes I will find the center of this hole. The similar process I will follow for everyone. So arbitrary 3-point circle center, similarly circle center, then two nodes between. Here also circle center, N1, N2 nodes between. Circle center, nodes between. Circle center, and a node between. So now I will off this and delete those nodes which are the circle center. So only I will have those nodes which are the center point of all my holes, where either I have to apply forces or constraints. So I have the center nodes of all these where I am going to apply. Here I am going to apply the constraint, these two and this one, and on this side I am going to apply all the forces. So Here I am going to apply a constraint. This one is constraint, so I will highlight this. So this side constraint, I will this side constraint. Here apply the torque in opposite direction, and here I will apply the lateral forces and bump forces. So I will create the rigids first before applying the forces. So first is to create rigids, go to 1D page, rigids. In the dependents, select multiple nodes. So independent, select the center node. In dependent, select all these nodes. And deselect the center one because it's already selected, and click create. If you don't deselect the center one, you will get an error of the degrees of freedom. One or multiple nodes have been selected. So always make sure while you select for multiple nodes, just deselect, right click and deselect them, the center one. So there will be no errors. So deselect, create. Then this. Similarly, here I can pick like any node by face. So it selects all the node on this face and click create. So if I turn off this, you can see it has created the rigids. So now I will apply the force and movement on this rigid points, and it will equally distribute towards the surface of those holes. So instead of applying the forces and counting the nodes and equally distributing, I can create rigids and just apply a force of here, it will equally distribute towards the entire surface. So first I will create a load collector as SPC, define a color, click create. And constraints the geometry. So as I have already told you, I am going to constrain this, and these 3 points and click create. Your constraints may be different. It depends on the cases which you are trying to simulate. So it depends on case to case. Now I will create one more load collector as torque, or you can say moment. Create and apply the moment. So this is in Z direction, you can see here. So let's assume in this point the moment is coming like 5000 Z direction, create. Similarly here the same amount in negative and create. So I have applied a moment here. Then if I put it like this, so I will have a bump force that is positive y-axis at this point. So I will create bump force, create. So analysis, forces, select a node, y-axis for say 12,000, create, and click return, and a braking force in negative z-axis. So braking force create forces of say negative 8,000 in x direction, and one more is axial forces. So lateral force create analysis forces of in positive z direction as say 5,000 on this node. Create reject forces of 5,000 in z. I'll put negative and say select this node and say create. So now if I turn off this, I have two movements at this point and three forces. One is bump, braking and axial force. So axial force you can consider on this direction also, depending on the case you are trying to solve, which you think the dominating, this direction forces will be dominating or this direction, that depends on your calculation. So I'm just showing the process to solve it. So I have these different cases. So now in this tutorial I am going to show you, I will create some more load cases. Like first I will solve when only movement is applied, when only lateral force is applied, when only braking is applied, when only bump is applied. Then I will solve when movement and lateral force is applied, when movement and brake is applied, when movement and bump is applied. Then I will solve when all these four forces are applied simultaneously. So in this way, I am just going to show you how you can combine the load and solve the analysis. So I will first create a load collectors when moment plus lateral force. Select a card image as load, click on create edit, enter here 2 because I am going to combine two load cases, S1 as 1, S1 2 as 1. This is the scale factor. If I want to increase in this load cards the movement application, so I can put it 2, so it will consider 10,000 here. Instead of 5,000 it will consider 10,000. Even if it's applied 5,000, you can multiply it with the scale factor. So I will select movement and lateral force. So this is my movement and lateral. Then movement and brake, create edit. Similarly I will add 2, here 1, here 1, movement and brake. I'll quickly check movement lateral whether I have given the correct load cards or not. So no, I have to give torque on this. So that was the correct one. So you can check here also. So I have given two load sets, that is movement, lateral, then movement and bump. Create edit, again 2. So in this way you can combine the loads. So torque and bump. Now I will have one more load case all combined. So I will click on create edit. I have 1, 2, 3, 4 cases, so I will add 4 here. For everyone I will put 1. Torque, bump, brake and lateral. So I will add all these forces in the one load case and see the deflection and stress values for this. So now I will create different load cases. So first, for torque, SPC will be SPC, load will be torque, create. Then bump, again SPC will be SPC, load will be bump, create. Then brake, create. Then lateral, SPC will be SPC, load will be lateral, create. Then movement, lateral, SPC will be SPC, load will be movement lateral, create. Then movement, brake. So SPC is SPC, movement, brake, create. Then bump, SPC will be SPC, movement will be bump, create, and all combined. So same SPC and all combined, create. So in this way I have a different load cases for different types of analysis. So now I will save this file and try to solve it. So analysis OptiStruct, export option to all, run option to analysis, memory option I will keep as 1000 because I think it may take some time, and click on OptiStruct. So I'm giving him the higher RAM memory so it will try to solve it faster. So now I got the results of knuckles for different load cases, and in the same file I will see the results of all. So I will turn off the rigid components. So displacement values, maximum displacement for torque, if I play animation, I will increase the deformation. So you can see this is torque. If I change the load case, bump, then brake, then lateral, then movement and lateral both combined together, movement and brake, movement and bump, and all combined. You can see the deformation value has increased when the combination of all the load cases were there. Similarly, I can see the stresses. So when all is combined, when only torque was there, when bump, for brake, for lateral, movement and lateral, movement and brake, movement plus bump. So these are the values for different load cases. So I have to consider the worst situation and try to optimize it for the worst case situation so that it will be safe for the worst one. Similarly, it will be safe for the rest one. So in this way, you can solve the knuckle problem in one file for multiple load cases. So now we'll move towards the hub geometry. For hub also, I will constrain it on this 4 bolt location and apply 3 forces. One is torque at this point, torque will be on this point, and 2 forces, that is lateral and bump at this point. So bump will be at this point. So these 2 forces I will consider on these points, and for hub I will create only one load case, that is when all is combined. When all the loads are acting at the same time, then what will be the results that I will see here. So braking is done. Analysis, forces, select this node. I'll apply 12,000 braking in y axis, say create, and a lateral force, create, forces, lateral force will be in z axis, same lateral force I will pick, create. So now let's assume my lateral force will be in opposite direction to the movement. So now I will create one more load collector, all combined. Give a card image as load, create edit. I have 3 cases, movement, braking, lateral. So I will add 3 here and I will combine all. So movement, braking, lateral, create a load step, all combined. SPC will be SPC, load will be all combined, and say create. Save this file. And perform the analysis. So I'll turn off these 2, the faces and this, and now we will see the results of displacement when all the cases I have combined, how it's going to work when I have all the cases combined. So you can see so this is my actual shape and then this is my deformed shape. Similarly, I can go for stresses. So my maximum stresses are coming at this point, the constraint location. So in this way, you can calculate the deformation and stress values for the different load cases. So I have already applied a huge amount of force, that's why the stresses are coming high. But my aim is to show you the process, how to solve it. So the loading conditions and the directions, everything you have to consider as per the practical approach for your hub and knuckle. but the approach will be same. So whatever the case you select, you have to follow this approach to get the results. So thank you very much for attending this session. So if you have any queries, feel free to ask us at edu-support@india.altia.com. Thank you very much.